Hello all, welcome back to another video. In this video we are going to study a new topic, that is basic properties of soil from Geotechnical Engineering. Here we are going to discuss some questions. Along with that we will cover this topic also. So first question, the specific gravity of a soil sample is 2.7 and E is void ratio is 0.945. If it is fully saturated, what will be the moisture content of the soil? So in this question we'll go through different terms like specific gravity, void ratio, moisture content. So first we want to discuss some basic topics from these basic properties of soil. After that we will discuss this question. First we are going to study soil water relationship. Soil water relationships. In this topic we will cover the terms like void ratio, porosity, degree of saturation, etc. So first if we consider a partially saturated soil, it contains soil solids, water and air. So if we draw we can represent the soil solids, air and water like this. Here soil solids, here it is water, here air. In case of partially saturated soil, the voids get occupied by water and air. And next case is if we consider a fully saturated soil. Here what we can see is soil solids and the voids get occupied by water only. Fully saturated means all the voids get occupied by the water. So here it is soil solids and the remaining portion get occupied by water. This is fully saturated in case of a fully saturated soil. If we consider a dry soil, what the case become is, in case of water what will comes? Air. Here it is soil solids. Okay, the remaining portion is air. And we can say that in partially saturated soil, here three terms there: soil solids, water and air. So we can say it is a three-phase diagram. Here we discuss about soil solids, water and air. So it is a three-phase diagram. And in case of fully saturated soil and dry soil, we can see only two-phase diagram. That means either soil solids or water, or solids and water in case of fully saturated, and soil solids and air in dry soil. So it is a two-phase diagram. And for studying the basic terms, we want to consider the three-phase diagram. Okay, this is a three-phase diagram. Here we can see so many symbols. On the left side of the soil, this three-phase diagram, we are discussing about volume symbols. These are our volume symbols, and to the right of the three-phase diagram we will discuss it with weight symbols. Okay, volume symbols and weight symbols. Then first is volume symbols. VA is denoted as the volume of air. VA is volume of air. Next term is VW. VW is volume of water. Okay, next term is VS. VS is volume of soil solids. Okay, so these are the three terms: VA, VW and VS. Then next we are going to study the term VV. VV is volume of voids. And we can say this volume of void is volume of air plus volume of water. So volume of void means volume of air plus volume of water. Okay, next term is V. Capital V means total volume of soil, total volume of voids, and we can say total V is equal to VA plus VW plus VS, or we can say V is equal to VA plus VW is VV plus VS. Okay, these are the volume symbols and the relations we want to study with this symbol picture. Okay, then next if we are going to discuss on weight symbols. First is WA. WA means weight of air. It's generally taken as 0. WA is equal to 0. Then next term is WW. WW means weight of water. And the next term is WS, that is weight of soil solids. Okay. Here we write volume of void is volume of air plus volume of water. Similarly, we can write weight of volume. Weight of volume. WV is weight of volume. Weight of voids. Weight of voids, that is WV is equal to weight of air plus weight of water. Here weight of air is 0. So we can say weight of void is equal to weight of water. Okay. Weight of void is equal to weight of water. Next term is capital V, that is the total weight of soil. Total weight of soil. So here we can write the relation capital W is equal to weight of air plus weight of water plus weight of soil solids. We can also write as here A is equal to 0. So weight of total weight is equal to weight of water plus weight of solids, or we can write total weight is equal to weight of voids plus weight of solids. Okay. So hope you all got this. Next we are going to discuss some important terminology. First is void ratio. Void ratio, and the void ratio is denoted by small e. And we have the equation void ratio is equal to volume of voids by volume of solids. And we can write volume of voids are VV and volume of solid as VS. So we can write void ratio is equal to VV by VS. VS is volume of solids. Okay. This is a relation between volume of voids and volume of solids to void ratio. The next term is porosity. Porosity. And is represented by small n. Porosity n is equal to volume of voids to total volume. So we can write volume of voids VV by total volume capital V, or we can write volume of void by capital V is volume of void plus volume of solids. So this is a relation between this porosity and volume of voids and volume of solids. And there is one important thing, void ratio, range of void ratio. Value of void ratio is always greater than 0. This is very important. In so many examination, this question is asked. Range of void ratio, they give some options, and from that we have to select the correct one. So always the value of void ratio is greater than 0. The next is void ratio. The value of void ratio is, the range is 0 less than n less than 100. This is the value range for porosity, 0 less than n less than 100. And there is one more thing regarding this void ratio and porosity, relation between the void ratio and porosity. We can write E is equal to n by 1 minus n, and n is equal to E by 1 plus E. This is very important. By giving the value of E, we have to find out n. Likewise, so many questions is there. So by heart this equation, E is equal to n by 1 minus n and n is equal to E by 1 plus E. So void ratio means volume of voids by volume of solids. Its value is always greater than 0, and we can write void ratio in terms of porosity, that is E is equal to n by 1 minus n. The next term is porosity. Porosity, if we consider porosity in the denominator, total volume is there. So porosity we can define as the volume of voids to total volume of soil, not soil solids, total volume of soils. And the range is 0 less than n less than 100. And the relation between n and E is n is equal to E by 1 plus E. So these two equations are very important. You have to buy these values also very important. Okay. Sometimes volume of voids and volume of solids will be given. We have to find out E. So all these equations are very important. So we studied two terms, void ratio, porosity, that's very important. That's values also important. The next term we are going to study is degree of saturation. Degree of saturation. Degree of saturation is denoted by S. So we can define S as volume of water. It's a ratio of volume of water to volume of voids. So we can define degree of saturation as volume of water to volume of voids. Volume of water to volume of voids. Here the value varies from 0 less than or equal to S less than or equal to 1. If in case of percentage, we can write 0 less than or equal to S less than or equal to 100. So this is the value, the range of degree of saturation. This is also very important. In case of porosity, there is no this equal sign. In case of porosity, 0 less than n less than 100. Not get confused with these values. In case of degree of saturation, less than or equal to. This is also very important. Okay, degree of saturation, we can say volume of water to volume of voids. Ratio of volume of water to volume of voids. That is the degree of saturation. The next term we are going to study is air content. Air content. Air content is denoted by AC. AC, and its range is 0 less than or equal to AC less than or equal to 1. If it is converted to percentage, instead of 100 will come. Okay, 0 less than or equal to AC less than or equal to 100. That's a air content range. Though, so what is air content? We can define air content as a volume of air divided by volume of voids. Volume of voids. So volume of air divided by volume of voids, air content. So air content is equal to volume of air divided by volume of voids. This is also very important. Okay. So we studied degree of saturation, air content. Two more terms. So there is a one relation between degree of saturation and air content. That is degree of saturation plus air content is equal to 1. If we give these in some questions, degree of saturation, they give in degree of saturation we have to find out air content. So very easy. You have to just subtract one value from 1. If S is given in percentage, we can say S plus S and AC in percentage, we can say S plus AC is equal to 100. If it is in decimal, we can write S plus AC is equal to 1. Okay. So first we studied void ratio, porosity, their ranges, their interrelationship. Then next is degree of saturation and air content. Degree of saturation is denoted by S and the value range is 0 less than or equal to S less than or equal to 1. And what is degree of saturation? Degree of saturation is volume of water to volume of voids. Next term is air content denoted by AC. Its range is same as that of S, that is 0 less than or equal to AC less than or equal to 100. Definition is it is the volume of air to volume of voids. Volume of water to volume of void is degree of saturation. Volume of air to volume of void is air content. Next term we are going to study is percentage air voids. Percentage air voids. percentage airwords Na. Okay, here its value range is 0 less than or equal to Na less than or equal to n, not 1 n. 0 less than or equal to Na less than or equal to n. So what is percentage airwords? Percentage airwords means volume of air. It is a ratio of volume of air to total volume. Total volume is percentage air content. Here it is percentage air content. Percentage air content. So total volume is there. So in case of porosity also, if it is start with P, porosity, percentage airwords. So in the denominator total volume will come. Just think like that. So you will not get confused. Okay. In case of porosity, in the denominator total volume will come. In the same way, in case of percentage airwords, in the denominator total volume. Okay. So percentage air content, volume of air to total volume, and its range is 0 less than or equal to Na less than or equal to n. And there is one relationship between Na and AC, that is percentage air content and air content. Sorry, percentage air voids and air content, that is Na is equal to n into AC. Na is equal to n into AC. This is also very important. Na is equal to n into AC. Okay. Next term we are going to study is water content or moisture content. Okay, water content also called moisture content, and it is denoted by small w. Water content denoted by small w. Okay. Small w is equal to weight of water divided by weight of solids. In the about up to this percentage airwords, we discuss about volume symbols or volume parameters. We are discussing about volume parameters. In case of void ratio is volume of voids to volume of solids. Porosity, volume of voids to total volume. Then next, degree of saturation, that is volume of water to volume of solids, volume of voids. Next is air content, that is volume of air to volume of voids. And last, percentage air voids, volume of air to total volume. In all these 5 terms, we discuss or we define the terms in terms of volume parameters. Next, we are going to study a terminology that is a ratio between the weight parameters. Okay, that is water content W, and is denoted by weight of water by weight of solids. That is the ratio of weight of water to weight of soil solids. And the water content is always greater than 0. So the value of water content is greater than or equal to 0. So these are the important terms we discussed. E, void ratio, N, porosity, S, degree of saturation, AC, air content, Na, percentage air voids. And these are the values. This is very important. E always greater than 0. Range of N, 0 less than N less than 1. Degree of saturation and air content, 0 less than or equal to S or AC less than or equal to 1. In case of percentage air voids, 0 less than or equal to Na less than or equal to N. And water content or moisture content always greater than or equal to 0. Okay, one more thing. We consider fine grained and coarse grained soils, void ratio, and in case of void ratio and water content, higher value is for fine grained soil. Okay, fine grained soils, void ratio and water content is higher than that of coarse grained soil. This also, just remember this whole point. Next, we are going to study specific gravity. Mainly 2 specific gravities, that is, one is true specific gravity. True specific gravity, or we can say absolute specific gravity. Absolute specific gravity or true specific gravity denoted by GS. GS. Okay. So what is GS? So specific gravity GS, true specific gravity or absolute specific gravity, is defined as the ratio of unit weight of soil solids to unit weight of water at 27 degrees Celsius. And the next term is mass specific gravity or bulk specific gravity or apparent specific gravity. Apparent specific gravity. Mass specific gravity, bulk specific gravity or apparent specific gravity. Both the three are same. And it is denoted by GM. Mass specific gravity, mass, bulk, apparent. Then in case of true specific gravity, another name of true specific gravity is absolute specific gravity. Okay. Mass specific gravity GM, it is defined as the ratio of bulk unit weight to unit weight of water. Bulk unit weight to unit weight of water. So these two are important. And there is one relation between GM and GS. That is GM is equal to GS by 1 plus E. Sometimes questions may ask related to this equation also. GM is equal to GS by 1 plus E, and the value of GM is always less than GS. Value of GM is always less than GS. So here we discuss about specific gravity, true specific gravity and mass specific gravity. True specific gravity is also called absolute specific gravity. It is defined as the ratio of unit weight of solids to unit weight of water at 27 degrees Celsius. And next is mass specific gravity. It is also called bulk specific gravity or apparent specific gravity, denoted by GM. GM is the ratio of bulk unit weight to unit weight of water, and there is one relation between this mass specific gravity and true specific gravity, that is GM is equal to GS divided by 1 plus E, and the value of mass specific gravity always less than true specific gravity. So okay, these are the important points that we have to learn from this topic, specific gravity. And GS, this is the value of GS is always constant, and GM is not constant. Okay, it may varies. Next we are going to study the value range of this absolute specific gravity GS. GS value is 2.65 to 2.80. This is for inorganic soils. Inorganic soils value of specific gravity ranges from 2.65 to 2.8. And in case of organic soils, the value varies from 1.2 to 1.4. Okay, 2.65 to 2.80 for inorganic soils, and for organic soils the value varies from 1.2 to 1.4. Okay, this all regarding specific gravity. Okay, let's learn some more equations. After that we move into the questions. Next we are going to study unit weight of soil. Different type of unit weight. First type is bulk unit weight. Bulk unit weight of soil. Bulk unit weight denoted by gamma T. Bulk means total, gamma T. Or we can say wet unit weight. Okay, wet unit weight. Bulk unit weight is also called a wet unit weight. Maybe in the question there is no term like bulk unit weight, just find out wet unit weight. So we have to find out bulk unit weight, total unit weight. So gamma T we can write, we can say total unit weight or bulk unit weight, wet unit weight. Gamma T is equal to total weight divided by total volume. Total weight of soils divided by total volume of soils. That is bulk unit weight. Second term is dry unit weight. Dry unit weight denoted by gamma D. Dry, gamma D. So gamma D is weight of solids to total volume. Weight of solids to total volume. Okay. Third term, these all are important. Okay. These equations are important. Bulk unit weight, total volume to total weight to total volume. Dry is weight of solids to total volume. Okay. Next term, saturated unit weight. Saturated unit weight denoted by gamma saturated. Gamma sat. Saturated unit weight. So saturated unit weight is equal to weight of saturated soil. Weight of saturated soil by volume of soil. Weight of saturated soil. So weight of saturated soil means there it includes weight of solids is there plus weight of water divided by total volume of soil. That is gamma saturated. Okay, so gamma saturated is equal to weight of solids plus weight of water divided by total volume. Okay, so next term is submerged unit weight. Submerged, don't get confused with these terms. Submerged unit weight of soil denoted by gamma sub. Sub means submerged. So submerged unit weight is weight of submerged soil by volume of soil. Weight of submerged soil divided by volume of soil. There is another relation. Gamma submerged is equal to gamma saturated minus gamma W. So gamma submerged is equal to gamma saturated minus gamma W. Then next another term is unit weight of solids denoted by gamma S. So simple, isn't it? Weight of solids divided by volume of solids. Okay, one more thing. We can take the value of gamma W. Okay, I will write here gamma W. You can take the value of gamma. If it is not given in the question, we can take the value of gamma W as 1 gram per cc, or if rest of the values are given in gram per cc, or it is 9.81 kilonewton per meter cube, or we can say gamma W is equal to 1000 kilogram per meter cube. These are the three values according to these different units. Okay, if it is given in the question as gram per cc, you can take the value 1. If it is kilonewton per meter cube, you should take it as 9.81. In some questions it is given as 10. If it is not given, the value is not given, then you can take it as 9.81. And gamma W is equal to 1000 in case of kilogram per meter cube. Don't get confused or don't get wrong while doing the problems. Okay, 1 gram per cc, 1000 kilogram per meter cube, or 9.81 kilonewton per meter cube. Okay. The next term is unit weight of water. Unit weight of water, that is gamma W. So gamma W is weight of water by volume of water. Weight of water by volume of water. So weight of water by volume of water is gamma W. Weight of solids to volume of solids is unit weight of solids. Okay, so these are the important terms coming under unit weight of soil. So let's see these terms one more time. First we studied bulk unit weight. Bulk unit weight is wet unit weight, total unit weight. So gamma T denoted by gamma T, W by total volume of soils divided by total weight of soils divided by total volume. Next is dry unit weight, gamma D, that is dry unit weight, WS. There is no water content, so WS divided by total volume. Dry unit weight of solids. Okay, then saturated unit weight denoted by gamma sat. It is the ratio of weight of saturated soil divided by volume of soil. Okay, next is submerged unit weight. weight of submerged soil divided by volume of soil, and also there is one relation between gamma submerged and gamma saturated. Gamma submerged is equal to gamma sat minus gamma W. Next is unit weight of solids, that is weight of solids to volume of solids. Then unit weight of water, that is weight of water to volume of water. Okay. And the values of gamma W, 1 gram per cc, 9.81 kilonewton per meter cube and 1000 kilogram per meter cube. Okay. And there is one more thing from this topic. We studied these 5 unit weights: bulk unit weight, dry unit weight, saturated unit weight, submerged unit weight, and unit weight of solids. Out of that, we have to write which one has the highest order or highest value. So there is one increasing order, or we can write in the decreasing order of these values. This is also very important. This is one previous year question. So we can write this in the order as gamma solids greater than gamma saturated greater than bulk unit weight greater than dry unit weight greater than submerged unit weight. This is the decreasing order of unit weights. This is very important. This is a previous year question also. Okay. Gamma solids. So first solids will come. Gamma solids, gamma saturated, bulk unit weight, gamma dry, and gamma submerged. Okay. So here we discuss almost all topics in the initial. So next, some important equations we want to write. Study these equations, then only you can solve every problems coming from this side. Okay. First is volume of solids. Okay. Just write the equation that we studied now. That is, first is void ratio is equal to n by 1 minus n, or n is equal to e by 1 plus e. Okay. Then s plus ac is equal to 1, we studied. Then Na is equal to n into ac. Okay. Then what more, anything? Oh, one important equation we forgot to study is very important equation. Wg is equal to Sg. That is the relation between void ratio, water content, specific gravity, and degree of saturation. Wg is equal to S. This is very important. Very important. Okay. We have to add the same equation here. Wg is equal to Se. If any one of the value is missing here, so we can find out the value by using the equation Wg is equal to Se. If W is, we have to find out W, and rest of the value is given. Just put all the values in this equation and find out the value of W. Okay. Next, we studied Gm. Gm is equal to Gs by 1 plus E. Here Gm is less than Gs. Okay. Then bulk unit weight. Bulk unit weight is equal to total volume of soils to total volume. These are the basic equations that we study. Many more equations are there. So let's see the one by one. If in case of embankment, if in the question it is mentioned as embankment, or it is given volume of soils and volume of voids as the initial void ratio, final void ratio, like that, if it is given in the question, we can use the equation V1 by V2 is equal to 1 plus E1 by E2 is equal to gamma D2 by D1. Gamma D is dry unit weight. Okay. This is the equations we have to use if in the question it is mentioned as embankment, or initial void ratio is given, initial dry density is given, we have to find out the final volume. So in that all case, we can use the equation V1 by V2 is equal to 1 plus E1 by 1 divided by 1 plus E2 equal to gamma d2 by gamma d1. Okay. The next equation is weight of solids. Weight of solids is total weight by 1 plus W. This is the relationship between weight of solids to water content. If weight of solids is given and the total volume is given, we have to find out the water content. So we can use the equation WS is equal to WS, that is weight of solids. WS is equal to total weight W divided by 1 plus W. This is total weight. This is small w, that is water content or moisture content. This is weight of solids. Okay, this one is our important equation. WS is equal to W by 1 plus W. Okay, next equation is gamma saturated. We can write not gamma saturated, gamma bulk. Bulky gamma. So equation is G plus SC by 1 plus C into gamma W. All the equations we can, most of the equations we can derive from this single one. So just study this one. Okay, bulky unit weight gamma T is equal to G plus SC by 1 plus C into gamma W. If we want to find out dry unit weight, what we have to do is, in case of dry unit weight, there is no water. So degree of saturation is 0. So just put the value of S as 0, we get G gamma W by 1 plus C. Okay, from the single equation we get one more equation, that is gamma D is equal to G gamma W by 1 plus C. Okay, then next equation, gamma D is equal to G gamma W into 1 minus N. G gamma W by 1 plus E, this is in terms of E, and another equation in terms of N, that is G gamma W into 1 minus N. For all these derivations are there, I just discuss the equations only. Okay, so gamma D is equal to G gamma W into 1 minus N. Then next one more equation in terms of percentage air void, that is 1 minus Na into G gamma W by 1 plus Wg. Here three equations for gamma D. In terms of E, we can use the equation G gamma W by 1 plus E. In case of N, equation is G gamma W into 1 minus N. In terms of percentage air void, water content, what we use is 1 minus Na into G gamma W divided by 1 plus Wg. Okay, this is the three equations for dry unit weight. Next we are going to study relationship between dry unit weight, bulk unit weight and water content. This is one important one. Dry unit weight is equal to bulk unit weight divided by 1 plus W. This is also important. Dry unit weight is equal to bulky unit weight divided by 1 plus W. Okay. Next we are going to study submerged unit weight, saturated unit weight minus water content. Okay. So we can write saturated unit weight. Here it is, if it is saturated, here S is equal to 1. So G plus C by 1 plus C into gamma W minus gamma W. So on solving we get gamma W into G minus 1 by 1 plus C. Okay. This is also important equation for gamma submerged. Gamma submerged G minus 1 into gamma W by 1 plus C. Okay. Next equation is for gamma saturated. Gamma saturated is G plus C by 1 plus E into gamma W. This one. G plus here. The main equation is bulk unit weight G plus SC by 1 plus C into gamma W. If we find out the dry unit weight, what we have to do is put S is equal to 0. Then we get dry unit weight. If S is equal to 1, we get saturated unit weight. Okay. So study this equation first. From that we will get the equation for dry unit weight and saturated unit weight. Then what do we do for submerged is just subtract gamma W from gamma saturated. Okay. This also easy. So two more is there for dry unit weight, that is quite tough for you. First, in terms of N, G gamma W into 1 minus N, that is in terms of N. Another is 1 minus Na percentage airwords, 1 minus Na into G W divided by 1 plus Wg. Okay. This is also important. Okay. Next is, this is very important. Most of the cases this equation we have to use this equation. Dry density is given, bulk unit weight is given. We want to find out water content. So gamma D is equal to bulk unit weight divided by 1 plus W. Okay, these are the equations. So just revise each and everything. First is V1 by V2 is equal to 1 plus E1 by E2 is equal to gamma D2 divided by gamma D1. This we use in case of embankment, or it is given as the initial volume ratio, initial dry density, or like that it is given in the question. We can use the equation V1 by V2 is equal to 1 plus E1 by 1 plus E2 equal to gamma D2 by gamma D1. Okay, second question equation, N is equal to E by 1 plus E, that it is the relationship between void ratio and porosity. N is equal to E by 1 plus E or E is equal to N by 1 minus N. Next is weight of solids. Weight of solids is total weight divided by 1 plus W. Small w is water content. This is the relationship between weight of solids, total weight and water content. That is, weight of solids is equal to total weight divided by 1 plus water content. Next is Wg is equal to Sc. Then next is bulk unit weight. Equation is G plus Sc by 1 plus E into gamma W. Next is gamma D, dry unit weight. Dry unit weight is G plus E. This term get 0. S is equal to 0. So G gamma W by 1 plus E. In case of N, it is G gamma W into 1 minus N. And in terms of percentage airworld, 1 minus Na into GW divided by 1 plus Wg. Okay, I will discuss how it comes. Here it is G gamma W by 1 plus E for dry bulk unit weight, dry unit weight. Next, in terms of E, N will come. So here we know the equation, N is equal to E by 1 plus E. Here it is 1 by E. So in case of 1 by E, we can write N by E. Okay. So every term, all the term like E, all the term means E. E should be replaced by N. So we can know E is equal to N by 1 minus N. So here it is 1 by E will come. I will show you. 1 by E means G gamma W into N into 1 by E. N by E means N into 1 by E. So E is N by 1 minus N. So 1 by E is 1 minus N by N. Okay. So 1 by E we can write as 1 minus N by N. Here is this N and G gamma W. These two get cancelled. The remaining is 1 minus N into G gamma W. So dry unit weight is G gamma W into 1 minus N in terms of N. Similarly, we can derive in terms of Na. Okay. Next is gamma D is equal to gamma T, bulk unit weight by 1 plus W. Then next is gamma saturated, G plus E by 1 plus E into gamma W. Then one more equation is there in terms of porosity. Gamma saturated is equal to G gamma W into 1 minus N plus N gamma W. This is the simple derivation. Here 1 plus E we can use E is equal to N by 1 minus N. We know the equation E is equal to N by 1 minus N. And we can know E is equal to E by 1 plus E. These two equations are we studied these two equations, and we can write 1 plus E is equal to E by N. 1 plus E by N. So just substitute E by N for 1 by 1 plus E. So the equation becomes G plus, in case of every E should be replaced with N. So G plus E is equal to N by 1 minus N divided by 1 plus E become E by N. On solving we get, okay, just cross multiply and do this. G into 1 minus N into gamma W plus N gamma W by 1 minus N into this E by N goes to numerator like N in N by E. Okay, just multiply, the denominator is E by N, just multiply with its reciprocal. So N by E, and on solving we get this steps. Okay, in this step just rewrite the things, and N by 1 minus N into 1 plus 1 by E. Just write like this. N by 1 minus N, that is E. This 1 by E get cancelled. So finally we get the equation G gamma W into 1 minus N plus N gamma W. Okay, the next equation is NA is equal to NAC. Then next S plus AC is equal to 1. So we can find out S as S is equal to 1 minus AC, or AC is equal to 1 minus S. Then next, the last equation, mass specific gravity in terms of true specific gravity and void ratio. GM is equal to GS by 1 plus E. Okay, so we covered almost all equations. So let's start with our problems, questions. Okay, first question. The specific gravity of a soil sample is 2.7. Specific gravity denoted by G is 2.7, G is 2.7 and E is 0.945. If it is fully saturated means degree of saturation S is equal to 1. What will be the moisture content of soil? Moisture content or water content denoted by W. So how we solve this problem? Okay, just write what all properties is given in the question. Specific gravity G 2.7, void ratio E is equal to 0.945, and the degree of saturation S is equal to 1. We want to find out W. W is water content. So we know the equation WG is equal to SC. Just substitute W. We want to find out G is 2.7, degree of saturation 1, and E is 0.945. So W is equal to 0.945 divided by 2.7. So W is 35%. On solving we get W is equal to 35%. So our answer is 35%. Option B is the correct answer. Okay, next question. Okay, the true and apparent specific gravity of a fully saturated soil are 2.7 and 2 respectively. True specific gravity denoted by GS, true or absolute specific gravity. Apparent specific gravity, another name for apparent specific gravity, bulk specific gravity, mass specific gravity, okay, denoted by GM respectively. So void ratio, we want to find out void ratio denoted by E. Okay, true specific gravity, another name for true specific gravity is absolute specific gravity. Okay, we want to revise each and every term that we studied through each questions. Okay, so that's why I just tried the another name for true specific gravity, apparent specific gravity, all. Okay, let's do this problem. And one more thing, specific gravity of a fully saturated soil. Fully saturated soil means degree of saturation S is equal to 1. So just write the terms that given in the question. GS is 2.7, GM mass specific gravity or bulk specific gravity is 2. Okay, degree of saturation is 1. So we want to find out E. So what is our equation? Equation is GM is equal to GS by 1 plus E. So GM is 2.7. GM is 2. GS 2.7 divided by 1 plus E we want to find out. So 1 plus E is equal to 2.7 by 2. So it is 1.35. So E is equal to 1.35 minus 1. So 0.35. So our answer is 0.35, option D. Option D is the correct answer. Okay. Next question. Water content of the soil can. Options: never be greater than 100, be less than 0%, take values only from 0 to 100, be greater than 100%. So water content of the soil, we studied water content of the soil range is greater than or equal to 0, isn't it? What is water content? Water content of the soil is weight of water to weight of solids. Okay. W always equal or greater than 0. So let's check which one is the correct option. Never be greater than 100. No, it is maybe greater than, always greater than 0. Be less than 0. B takes value from 0 to 100%. Be greater than 100. Maybe greater than 100. So water content of soil can be greater than 100. So our in this the correct option is D. Okay. 3. Next question. A soil has bulk density. Bulk density gamma T is given as 22 kilonewton per meter cube and water content is given 10% dry unit weight of soil gamma D. We studied this equation, isn't it? Okay. Bulk unit weight gamma T is equal to 22 kilonewton per meter cube. Water content is given as 10%. We can write it as 0.1. Then gamma D. Gamma D is equal to gamma T divided by 1 plus W. Gamma T by 1 plus W is 0.1. It is 1.1. So our answer is 20 kilonewton per meter cube. Okay. Here option B will be the correct answer. Next question. Valid range for the percentage voids N is. Valid range for the percentage voids N. But N is denoted by porosity, isn't it? Yes, okay. Let's percentage voids. So what is the range of porosity? 0, less than N, less than 100. This is the value of porosity. Okay. Not equal to sign. This equal to sign is coming for S and air content. Okay. Okay, next question. If the volume of void is VV is equal to volume of solids, that is Vs. Okay, volume of solids is Vs. Then the value of porosity is denoted by N and the void ratio E. Okay. It is given volume of void is equal to volume of void. So we can say volume of void is equal to volume of solids. And we want to find out N, porosity and void ratio E. Okay. What is porosity N? Volume of voids to total volume. Total volume means volume of voids plus volume of solids. Here it is volume of void is equal to volume of solids. So we can write volume of void divided by volume of void is both are same. Okay. So the value become volume of void is by 2 volume of void 1 by 2. That is 0.5. Value of N is 0.5. Next E. E is volume of voids to volume of solids. So volume of void both are same. So 1. Value of E is 1. So N and 1 is 0.5 and 1. Option C is the correct answer. Okay. See, this is the sixth question. Next question. If the degree of saturation of a partially saturated soil is 60 degree of saturation is denoted by S. Then air content of the soil is AC is okay. Degree of saturation is given. S is given as 60%. AC is S plus AC is equal to 100. So AC is equal to 100 minus 60. 40%. So option is the correct answer, 40. Next question. Eighth question. How many cubic meter of soil with void ratio 0.6, void ratio E 0.6 will form 100 meter cube of soil, volume of soil with a void ratio E 0.9. Here we have two void ratio E1, E2, isn't it? Okay, so we know what equation we have to choose here. So just write what all things given in the question. Here it is given void ratio E1 is equal to 0.6, E2 is 0.9, will form the volume of voids, okay, will form 100 meter cube with the void ratio 0.9. Okay, we want to find out V1. Okay, so we know the equation V1 by V2 is equal to 1 plus E1 by 1 plus E2. Okay, just substitute the values. Then V1 by V2 is 100 equal to 1 plus 0.6 by 1 plus 0.9. So V1 is equal to 1.6 by 1.9 into 100. On solving we get 0.842 into 100, that is 84.2. So here the volume is, from the option, the most accurate answer is 84 meter cube. So the answer is option C. Okay, in this video we studied so many equations and 8 questions also we studied, and the remaining questions we will study in the next video. More than 70 questions we are going to discuss from this chapter, basic properties of soils. Okay, remaining questions we will discuss in the next class. Thank you for watching. Keep on watching, and if you have any doubts regarding these topics, just comment and I will clear that topic in the next video also. Okay, thanks for watching. Keep on watching.